Today's class is going to be on the quotient rule. Remember, we've gone through some of the topics in this applied mathematics. We discussed about the inverse square law. Check on its application in our course. There's a video. We talked about the geometrical sharpness. We also check on the application, the same in our course. We can handle the exponential. We did realize that exponential application or exponential principles help radiographers to understand various aspects of decay series and even the time, the exposure time plus the depth that the dose is expected to traverse the tissues. Now, exponential law is just but a branch of mathematics. It's a branch of mathematics that fundamentally deals with the rules of differentiation of exponential functions. And maybe we'll take an example. And before we take an example, what we're going to do, we're either going to dwell on the quotient rule, that is the product and quotient. Quotient, you understand, these are basic principles in mathematics. Quotient rule, nothing other than division. So what's up? Then when we talk about the product rule, product is different multiplication, and we understand how quotient and product rules are applied in mathematics, particularly to the calculus. So we'll take an example, or maybe before we take an example, we can write something. Say that quotient and product rules, quotient and product rules, quotient and product rules are fundamental rules. They are fundamental rules. They are fundamental rules for differentiating exponential functions. For differentiating exponential functions. Then we start with the quotient rule. And we take an example where we have example 1. We have y is equal to exponential x over x squared. Also, say here. So they're moving to give you 2 of them. Only one. Okay, let's move to the next example. That is okay. We have exponential 3x, then x cubed, x power 3. I said that before you do this, you first understand, you split them into 2, isn't it? In terms of u and v. So in this case, our u is going to be, then we have our v equal to x. Then we say that we apply the exponential rule or exponential formula that says that y will be equal to first derivative of u multiplied by v minus first derivative of v multiplied by u. So before that, first derivative of v dot u, isn't it? Then you divide by, with this respect, what is our u? U is e, isn't it? What is our u? First derivative of u. First derivative of u. What could be our first derivative of u? Having gone through this class and done one example, what is the first derivative of u? It will be what? It will be 3 e to x. Good. What about v? Our v is x cubed, x power 3, isn't it? Not cube, but x power 3. And they are just the same, isn't it? There's no difference. Eh? What about our first derivative of v will be 3x squared. And then we invoke the formula now, isn't it? When we invoke the formula, we'll be having our limit here. We are going to have formula. We have first derivative over this. What is our limit? What is our derivative of 3x. Then we have our x cube, isn't it? Okay? Minus derivative of, we have 3x square. Then we have 3x over x over x. Then we square. When we square this in simple terms, we get nothing other than x raised to power 6. Then we said that up to this point, of course, we can leave our answer for this point, but we cannot. It seems having a question. What is it that you don't understand? I said that the formula. What is the formula? V square, isn't it? But our v is x power 3. X power 3 square is like x power 3. When you do this now, you invoke the product rule. So it will be x 3 plus 3. That's x plus 6. So in that case, you're having x power 6. And up to this point, let some other people leave it at this point. But as physicists and mathematicians, we're not supposed to leave our answers at that point. If we are asked by mathematical hypothesis and principles, that we make sure that we simplify our answers to the simplest form. Now, up to this point, what is it that can be factored? What is common up here? What's common here? I can see 3. 3 is common, isn't it? Another thing that is common? X power what? X power 3. Isn't it? X power 3. Huh? We have x, isn't it? I think this x here. Are you seeing this x here? So x power 2 is common, isn't it? Together. What about exponential? Is it common? Right? Because here we have 2, here we have 3. So we've said that 3 is common, isn't it? So we have 3. Then we have x power 2, isn't it? X power 2. So it means that we are going to have 3x power 2 into exponential into x, exponential 2x minus e power 3x, isn't it? we have something of this kind. Over our x raised to 6. Then from here we can do some simplification again. We can still simplify further, isn't it? We have this and we have this. What happens? We have 3 into x into this one minus over x. Which power if it were there? Because 2 has gone. What many what category you have there? What do you do if you have this one? X power 2 over x power 6. Something like that. The same as x into 2 minus 6, isn't it? So we make x negative 4. X negative 4, you multiply this by x negative 4, will give us 4 down here. That is our end. This is the answer. Any question up to that point? Why? We're trying to substitute what?